Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. In this video, I will start the next chapter which is Congruence. So this is part 1 video on the chapter Congruence, where I will discuss about the congruent figures and types of congruent figures. So in this video, we will not yet start about the congruency of triangles, which is the main topic of this chapter. Congruent triangles we will discuss in the next video. So if you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So this video is part of the playlist CBSE Mathematics for class 7 following the textbook of author RS Aggarwal. So let's get started with this video. Okay, so I have my rough notes on the left hand side, and the right hand side I will do any kind of discussion. So in this video I will basically discuss about the very basics, that is the introductory part of congruent figures and types of congruent figures from the textbook of author RS Aggarwal. Okay, so what are congruent figures? Now you know that by figures we mean plane figures. Now plane figures, what are plane figures? Plane figures are figures that are closed and formed with line segments. So for example, we have a triangle. This is a closed figure. We have square. This is also a closed figure. We have parallelogram. This is also a closed figure. We have a rhombus. This is also a plane figure. We have any quadrilateral. These are all plane figures. But this is not a plane figure. Let's say this is not a plane figure. Also, this is not a plane figure. So I hope you understand what is meant by a plane figure. Okay. Now two plane figures are said to be congruent if they have exactly the same shape and size. As you can see, all the plane figures have a shape and they also have a size. Now two plane figures are said to be congruent if they have exactly the same shape and size. Shape we can inspect. We can verify the similarity between shape by seeing with eyes, but size we cannot immediately verify whether the size of two plane figures are same or not. So the method that we use to verify whether two plane figures are congruent or not is known as method of superposition. So what we do is, let's say the method what does the method does? Comparison of two plane figures is done by method of superposition, where one figure or object, these plane figures are also, we can also call them as object. So where one figure or object is placed on top of the other to see if they perfectly cover each other. So let's say I have a triangle. Let's say I have this triangle. Now if I draw, let's say, another triangle, now just by seeing with eyes, they may look similar. They may look that they have the same shape and size, but we cannot just with eyes we cannot tell confirmly that they are congruent. We have to use the method of superposition. So what is superposition? I would like to see if one figure, let's say the right hand side figure, perfectly overlaps with the left one. So if I move it and try to overlap, it will not overlap. I cannot overlap it. So this side is overlapping, but the other sides and the other sides or the angles are not overlapping. So it is not overlapping. So this means that these two shapes which are triangles are not congruent. So by the method of superposition only we can confirmly say that two plane figures are congruent or not. So two plane figures are congruent if their shape and size are perfectly same, and we use the method of superposition to verify that. Now, if there is an object or figure and its carbon copy are always congruent. So let's say I have this figure, I have this triangle. Now if I create a carbon copy of this, so I am creating a carbon copy, I am duplicating it. Let's say I am copying it and then I am pasting it. So I have this shape or figure which is a carbon copy of the this figure, previous one. Now if I want to see if this figure is congruent with the from the object from which I created this carbon copy, I can see that I can perfectly overlap. You see, they perfectly overlap, and you see one triangle. That is, one triangle hides the other perfectly. So they are perfectly overlapping each other, and hence they are congruent. So any object or figure and its carbon copy are always congruent. Okay. Now the next thing is two duplicate copies made from an object to same size are congruent. Let's say I have this original object or figure. I am doing all the discussion with respect to triangles, which also applies to any other figures, like it could be square, it could be parallelogram, rhombus, or quadrilateral, or circle, whatever. So I have this original. As you can see, this triangle figure is highlighted. Now I will create two duplicate copies of this object. So let's say I created one duplicate. This is one, and let's say from this. So this was the first duplicate I created. Now let's say I will create another duplicate. Let's say I create this. So now this was the original copy. This was the original. And this is duplicate 1, and this is duplicate 2. These two duplicates has been created from the original copy. Now if I want to see whether duplicate 1 and duplicate 2 are congruent or not, I will use the method of superposition. I will try to see if I can move this duplicate 2 and perfectly overlap with the duplicate 1. You see, it does. Duplicate 2 perfectly overlaps with duplicate 1, or even I can move this duplicate 1 to see if it perfectly overlaps with duplicate 2. Either way, they are perfectly overlapping. So duplicate 1 and duplicate 2 are congruent. Okay. Now let's. Now how do we mathematically express two plane figures to be congruent? So the symbol used is the notation used is two parallel lines, and above that you have this symbol which is known as tilde. So this is the symbol of congruency. So if you have any figure, so let's say this was triangle ABC. We always name a figure. This was triangle ABC and this was triangle PQR, and let's say this is triangle EFG. Now when we mathematically express a figure, what we do is we write a figure. I mean, instead of figure, it could be a symbol of triangle, or it could be in words like rectangle, circle, or square. So we first write the figure or any symbol related to the figure, and then we write the name of the figure, the naming of the figure. Just like in the triangle, we can say ABC. Now, okay, so the convention is we specify the figure, what type of figure it is. Now I am writing figure. It could be a symbol like triangle. We use a small triangle. We use this symbol for triangle. Instead of figure, it can be the small triangle. Or for squares, it could be SQ. Now, so the a word or a little symbol to that identifies what kind of figure it is, and then the name of the figure. So name of the figure, I am just writing it F1, and then we use the congruency symbol this, and then we write the other figure and F2. So this is the general format of expressing congruency between two figures. Okay. Now in the example, you can see we can using this format we can say triangle ABC is congruent to triangle PQR, which is also congruent to triangle EFG, because triangle PQR and EFG are duplicate copies of the original triangle ABC. So this is how we use the symbol of congruency. Now if the figure is a square, let's say if it is a square, let's say I have this square. So this I am doing a rough sketch. These figures are not perfect. So let's say I have A, B, C, D, and there is another square, let's say P, Q, R, S, and if they are congruent, we will discuss how two squares are congruent. If they are congruent, we will write it as, since there is no symbol used as per the textbook RS Aggarwal, there is no symbol used for squares or any other figures. It is written in words. So I will write for square SQ, and then the name of the square, the left hand side square, its name will be ABCD, and then the congruency symbol, and then the square PQRS. So this is how we use the symbol congruency to denote the two plane figures are congruent to each other. Okay. Now let's discuss some basic types of congruent figures. Okay. Now, so I hope it is very clear that two congruent figures two plane figures are said to be congruent only when both their shape and size are exactly the same. Now let's say I have this triangle. Let's say I have this triangle ABC. And before going on to the next topic, types of congruent figures, let me clarify one thing which is very important. So let's say I have a triangle ABC. Now let's say I create another triangle. Let me first okay, so I duplicate this triangle and I get this triangle, and now let's say now these two triangle, even though they may not look the same visually, but they are congruent triangles, as you can see. Now so the naming has to be proper, P, Q, R. So since I have created this triangle on the right hand side, which was a duplicate copy of the triangle on the left hand side, and I just changed its orientation. So what I mean to say is that the orientation of two congruent figures may be different. In these two triangles, they are congruent because their shape and size are same. How can I say that their shape and size are same? I can easily overlap both of them, and one will hide, and they will overlap perfectly. But visually, apparently, it seems that they are not, they will not overlap, or they are they do not have same shape or size. But indeed, they have the same shape and size. So orientation does not matter. As you can see, if I try to let's say if I try to move this, I know I cannot overlap like this. I have to change the orientation. So let's say if I what was the orientation of, I'm not sure. I have to perfectly make the orientation and see if it perfectly matches. You see, not perfectly matches. So these two, definitely these two figures are congruent. But if I just change the orientation, then also they are congruent, because congruency is related to the shape and size, not the orientation. So that was one thing I wanted to discuss. Okay. And also you can see that, let's say I have, let's say from this triangle on the right hand side, I create not this one, let's say from this one, from this triangle ABC, I create a duplicate, and then I change its size. If I change its size, let's say, sorry, if I want to change the size, you can see that this triangle, the lower one, the smaller one, it is of its size is not same as the this triangle EFG, even though it is looking its shape is perfectly the same as the triangle ABC, but its size is smaller than the triangle ABC. Therefore, triangle ABC is, I'm using this symbol, I'm crossing it to denote that they are not congruent, even though I do not know if this type of notation is used or not. Anyway, so I just mean to say that they are not congruent, even though their shape is same, perfectly the same, but their size are different. EFG triangle EFG is of smaller size. Okay. Now let's try to discuss some basic types of congruent figures. The first one is line segments. Now two line segments AB and CD are will be congruent just if the length of the segments are same. So let's say I have this line segment. So line segment, you have 2 points. So let's say AB, and if I create a copy, let's see if I can, yes, if I create a copy, you can see definitely that this line segment CD is of exact length as AB, as I copied it, as I duplicated it. So this will be, so we will have AB is denoting the segment, the line segment AB, even though in the book it is written as, line, as I said, as per the format, figure F1 congruent to figure F2. So line segment AB is congruent to line segment CD. We write this to denote that the two line segments AB and CD are congruent. Now also you see that if I create a duplicate, of this line segment, and let's say and then I rotate this, say this line segment is EF. So I will also have I'm in short writing LS for line segment. Instead of writing the line segment LS, I will also have LS. AB is congruent to LS EF, because they are having the same length. So two line segments, irrespective of their orientation, whether one is vertical or horizontal or what angle, it does not matter. Their length should be same. Then only two line segments having same length are congruent. That is the main concept. Okay. Now angles. Two angles are congruent if they measure same. Now you can see in the notes there are two angles, angle AOB formed by the rays OA and OB and another angle POR formed by the rays OP and OR, and they have their measures they measure same, that is x degree. So we will have angle AOB congruent to angle POR, that is because their measure are same. So we have so let's say I have this angle. I have this angle. Let's say this is A, this angle AOB, and let's say this be 90 degree AOB. Now also, so now I have another angle. Let's say this. Let's say this be POR. This is also 90 degree. So in this we can clearly see, since both the 90 degree, both angle measure 90 degree, we will have angle AOB is congruent to angle POR as measure of angle AOB is equal to measure of angle POR, which is equal to 90 degree. So the measure of the angle must be same, then only two angles are congruent. Let's take another example. Let's say I have an angle formed by the rays, let's say OA, and let's say this be OB. So this angle, let's say this angle be 30 degree. Now you can also, let's say another angle, let's say this is formed by the ray OP, and let's say the ray OR, and let's say this, the angle POR, the measure of the angle POR is also 30 degree. Even though I'm just trying to explain that even though the angles they may look it does not matter the position of the rays OP and OR, the position of the rays OP and OR, or the making the angle. It is just the measure of the angle that will matter in determining whether two angles are congruent or not. You can see in the angle AOB, the angle is made by the rays OA and OB. It is and the measure of the angle is 30 degree. But in the second angle POR, the rays OP and PR are quite different. Their position orientation is quite different from the rays OA and OB. But the fact is that the angle made by the rays OP and OR, that is POR, its measure is same, that is 30 degree. So we will have angle AOB is congruent to angle POR as measure of angle AOB is equal to 30 degree, and also measure of angle POR is also 30 degree. Okay, so this was congruency between two angles. Okay, squares. Now two squares are congruent if their sides are of equal length. You know, a square is a quadrilateral where all the four sides have the same length, all the sides are of equal length. So two squares ABCD, if one square, first square is ABCD and the second square is EFGH, then the square ABCD will be congruent to square EFGH if one side, that is any one side, since that is one side of the first square is equal to any side of the second square, because in a square all sides are of equal length. So if we have AD equals to EH, then the square will be congruent. We could have also written AB equals to EF. It would mean the same thing. They would be congruent. So for two squares to be congruent, it is just the requirement is that their side, their side should be of equal length. Okay, rectangles. Now in rectangles we know that we have a length and breadth, and of course these are the two these are the two properties of a rectangle, and of course all the corner angles are 90°. So length and breadth are the two properties of a rectangle. So for two rectangles to be congruent, we must have the length and the breadth equal. So you see in the figure, in the left hand side, the rectangle is ABCD, and in the right hand side, the rectangle is PQRS. So we will say that the ABCD, the rectangle ABCD will be congruent to rectangle PQRS only if the length. Please mind the ordering of the letters. Now, please note one thing, that so we have a rectangle. Let's say we have a rectangle. Let's say we have a rectangle this. Now this is, let's say we name this rectangle as ABCD. Now and also we have this other rectangle. Let's say this rectangle. They are congruent. They are definitely congruent, but they have some different orientation. Let's say this be PQRS. Now these two rectangles are obviously congruent, because let's say as let's say the length of the left hand side rectangle is, let's say this be x, and let's say the breadth of the first rectangle be y, and also in this case the length, let's be x, and the breadth be y. So we know that AB is equal to PQ, and also BC is equal to QR. We know this. Let's say we know this. So definitely then these two rectangles will be congruent. But when you will mathematically say that these two rectangles are congruent, you have to be very careful about naming the rectangles. If you name the first rectangle as ABCD, then you will write, so this is rectangle ABCD. So clearly, if you name the rectangle ABCD, you know that the adjacent sides are AB and BC in this rectangle ABCD. Now if you want to, then you have to carefully do the naming of the rectangle PQRS. Now if you while expressing the congruency, if you write the rectangle PQRS, if you write the rectangle, I can also on the rectangle on the right hand side, I can always name it as PSRQ, but this whole thing will be wrong. The rectangle PSRQ is actually not congruent to rectangle ABCD, because the ordering of the letters of the figures matters in both the figures while you are expressing congruency. Because if you write this, if you express the congruency that the rectangle ABCD is congruent to rectangle PSRQ, this will imply that AB is equal to PS and BC is equal to SR, which is not the case. In our figure. So this is wrong. This is wrong. The correct way, as per the figure, I am discussing how if ABCD is a rectangle where we can see the length is BC, the length are BC or AD is equal to X, and the breadth are AB or CD, which is Y, and on the right hand side the rectangle is if I say the rectangle is I have to mention the rectangle as PQRS. So if I write the rectangle ABCD is congruent to rectangle PQRS. This is correct because this will imply AB equal to PQ, because we are taking the first two letters from the left hand side rectangle ABCD, first two letters that will determine the one side. So similarly we will have to take the first two letters from the second rectangle, that is PQ. So we can clearly see that AB is equal to PQ, and this will also imply, this congruency will also imply BC is equal to QR. So we take the next, so that the side adjacent to AB is BC in the rectangle ABCD. So the corresponding side will be in the rectangle PQRS, the corresponding side will be QR. So we must have BC equals to QR, which is correct as per our figure. So as part of our figure, we have to mention the congruency of these two rectangles as rectangle ABCD is congruent to rectangle PQRS and not rectangle PSRQ. So this thing you have to be careful. Okay, so this was about a congruency between two rectangles. Two rectangles will be congruent only if they have the same length and breadth. Okay, circles is very simple. Two circles are congruent only if they have the same radius. If the radius is same, then two circles are said to be congruent. Now I just added one more figure. This is not given in the textbook. It is a rhombus. Now you know, in a rhombus, what are the properties of a rhombus? A rhombus has rhombus is a quadrilateral. It has four sides, and all the four sides are of equal length. They have same length, just like a square. But the difference is that in a square the diagonals are also of same length, but in a rhombus the diagonals are of different length. The diagonals could be of different length. A square is also a rhombus. I mean, a square is a special case of a rhombus. So in rhombus, in general, the diagonals are of different length. So let's say I have these diagonals, and also in rhombus the diagonals are of different length and they bisect each other at right angles. So if this is a diagonal of rhombus, now I can, obviously the other diagonal will bisect these diagonals at right angles, and I can draw the diagonals at any point, but I have to be careful that they both bisect each other at right angles. So let's say the other diagonal is this. So now no, this cannot be. I cannot draw. Sorry, I said that the two diagonals bisect each other at right angles. That is, the angle created by these two line segments will be 90 degree, as well as the point of intersection will be the midpoint of both the diagonals. So this is wrong. I have to first approximately locate the midpoint of this line segment over here, and then I can draw the other diagonal like this. Now I have these 4 points. These 4 points are the vertices of the rhombus, and if I connect them, I have the rhombus. So this is basically the structure of a rhombus, where the diagonals could be of different length, but they bisect each other at right angles, and also all the sides of a rhombus are same. So this side will be x, length of this side will be x, this will be x, and this side will be also x. So let's say this rhombus is ABCD. Now another rhombus, any other rhombus, will be congruent to this rhombus only if two rhombus are congruent to each other only when their diagonals are of same length. That is the length of the two diagonals of our two rhombus has to be same. If it is so, then those two rhombus are congruent. So let's say if I draw another
rhombus having the same length as the diagonals AC and BD in the rhombus ABCD. Let's say I first draw the rhombus BD, not the shorter rhombus vertically. Let's say this is the shorter rhombus. So the other rhombus will be definitely be horizontal, because it need to intersect these rhombus at 90-degree angle. So let's, and also they will both bisect each other. So approximately I can draw the other diagonal like this. Okay. Now if I connect these the points, they will be the vertices of the rhombus. So now let's say I name this diagonal as, name this rhombus as PQRS. Now how will I, clearly it is obvious that these two rhombus are congruent, because you can overlap, these two rhombus will overlap perfectly each other. Now I will not try this because the length of the two diagonals are not perfect. I just drew this diagram approximately. So now if I want to mention, express that these two rhombus are congruent, how will I do this? I cannot, let's see, if I do, I'm in short writing RH for rhombus ABCD. Let's say if I do this, rhombus PQRS, will it be correct? Will it be correct? Because we know now this, for a rhombus, I said that in a rhombus the diagonals should be of same length. Now if these two rhombus are congruent, then we know that in the rhombus ABCD the diagonals are AC and BD. So this will imply AD, not AD, but AC and BD. AC and BD, these are the two diagonals, and in this in the rhombus PQRS the diagonals will be similarly, you see the diagonals is AC, that is the first letter and the third letter, and the other diagonal is BD, that is the second letter and the fourth letter. Similarly, the two diagonals of the rhombus PQRS will be PR and QS. Now are they same? This has to be same. In the first diagram AC and in the second diagram PR, no, they are not same. They are not same. See, if I these two rhombus are congruent, that is for sure. But if I expressed the congruency between these two rhombus as rhombus ABCD congruent to rhombus PQRS, that is incorrect way of writing, because this will mean that AC is equal to PR and BD is equal to QS, because in the rhombus ABCD the diagonals are AC and BD, and in the rhombus PQRS the diagonals are PR and QS. And we can clearly see from the diagram that now let's say this diagonal, shorter one, is L, and let's say this is M. So definitely in this in the rhombus PQRS this will be M and this will be L. So in this case we will have PR equals to L and QS equals to M, and in this rhombus we will have AC is equal to M and BD will be equal to L. Now you check that AC, if we say that rhombus ABCD is congruent to rhombus PQRS, we are not having the fact that AC is equal to PR, because AC is M and PR is equal to L. So this is wrong. So the correct way we have to the correct way of expressing that these two rhombus are congruent has to be like this. Rhombus, we have to be careful, ABCD. So we can name the rhombus for congruency, the right hand one, as definitely with QRSP. We can write this. So this will imply AC, the diagonals in the rhombus ABCD are AC and BD, and the diagonals in the rhombus QRSP will be QS and RP, and definitely they are equal, because AC is equal to M and QS is also equal to M. So this is the correct way of expressing the congruency between the rhombus ABCD and the two rhombus above. So this thing you have to be careful regarding when you are mentioning, expressing the congruency between two plane figures. the naming, how you name the two figures is very crucial as per the ordering of the letters, especially in rectangles and rhombus and triangles. So this was all about this video regarding the congruent figures and types of congruent figures. I did not, so from the next video I will start about the congruency of triangles, which is the main topic of this chapter. So if this video was beneficial, then please like it and share it with your friends. And also once again, please support me by subscribing to my channel, and please do not forget to press the bell icon so that you will be notified by my future videos. So if you are not aware that I have created a new series of videos which is under the title Concepts to Remember. I just completed the series of videos on the chapter Properties of Triangle, where I discuss only the key points, the key aspects, formulas, and all the main types of patterns of problems that may come from a chapter. And all these videos are all these key concepts and the questions and patterns, formulas are divided into topics, in multiple topics. So if you, in the same playlist of CBSE Mathematics, CBSE Maths RS Aggarwal, you will see videos on the chapter Properties of Triangle, which is under section Concepts to Remember, and every topic also has some sample problems which you can solve to evaluate your understanding of the key concepts. So once this chapter is complete, that is congruence, I will make those videos on concepts to remember. This will be extremely helpful for you once you have completed a chapter. But the videos under concepts to remember, you should only watch them once you have completed a chapter and once you have done a lot of problem solving from a chapter. Then only it will help you. So those videos are must. Please check them out from the same playlist. So thanks for watching, and until the next video, take care and bye.